Having said that though, our designers have designed this in such a way that it is a very competitive machine. You get a lot of value for money, and it's not really a lot of difference in price than other lesser machines on the market.
Hello and welcome to another MTD podcast. This one's being filmed here at Nikken Innovation Centre in Rotherham. I'm with two gentlemen, Lee Scott and Tom Skabula. Good morning, guys.
Good morning.
Good morning.
Now, we've been here for a couple of days. The purpose of our visit has been to interrogate the technology that is behind me from Heckert. Interrogate's the right word, is it? Would you say?
Yeah, we've broken it down into bite-sized chunks.
We have done exactly that, and coming to our YouTube channel and the MTDCNC app and our website and all of our platforms in the near future will be a series of videos all about the compact range from Heckert. Now, we'll talk about all of the points that are covered on that series of videos during this podcast. It's going to last around about 30 to 40 minutes, but it's going to be packed with insights into what is on this machine, what it's equipped with, and why you should consider it to be in your machine shop. So firstly, Lee Scott, for people that don't know, perhaps you could just introduce yourself to our audience and tell us who you are and what you do as part of the Starrag Group.
Yeah, sure. Well, we're talking about Heckert today. So Heckert is part of the Starrag Group. It's a brand that's designed and built over in Chemnitz.
Before we do that, what about you? I want to know about you. Tell our audience who you are.
What about me? Sorry.
For those that have never seen you before, I know you've been on loads of videos with us in the past, Lee, but I want to know about you and,
Okay, well, I'm Lee Scott. I'm Director for Sales and Applications for UK. And I've been with Starrag now for 13 years, so I've seen a lot of growth, a lot of changes, a lot of innovation, and a lot of new products, which is what we're, of course, talking about today.
Okay, good. Right, now, so give us a brief on the compact range.
So the compact range
Or give us a brief on Heckert, actually, in general, because I know...
Well, if we start with Heckert, I mean, Heckert is, as I say, it's a German company, machines built over in Chemnitz, and Heckert is part of the Starrag Group. So what we do with Heckert is we build horizontal machining centres, mill-turn machines, ranging from 400mm pallet size up to 1.8 metres. So parts, if you like, from as big as your fist to anything that will fit within a 3.4 metre diameter swing on the machine. And we specialise in solutions for industries like aerospace and energy, transport and industrial type markets.
Okay, now Tom, you've been with us for the last 2 days looking at this machine. Coming from the machine from the shop floor, have you ever operated or used a machine of this ilk?
No, but I wish I had, because there's some points which we'll cover on this machine which could make your life so easy as a machinist.
Yeah, and give you the ability to get parts off of the machine and through the machine shop a lot faster, which I suppose is key, isn't it, to any machine shop these days?
Oh, definitely, yeah. This is a really quick, rigid machine with great accuracy, so there'd be no worries on what parts you could put through it, because you could put anything through it, to be honest.
Yeah. Well, we'll cover all that. Now we've got actually 12 points that we're going to touch on today. We're going to talk about the compact machine itself and the options available with the machine. We're going to talk about the spindle technology on the machine. We're going to talk about 4-axis horizontal machines, because this is a horizontal 5-axis machine. We're going to talk about 4-axis versus 5-axis, why you should select either or one or the other. We're going to talk about what impact speed, power and accuracy has for a company, and what this can deliver in those areas. We're going to talk about work holding on the machine. We're going to talk about process integration. So we know that this is a highly capable machine, but what else do you need to keep process security? We'll talk about the options on automation, pallet changers, gantry loaders. We'll also talk about the HMI, how that can support or help machinists be able to operate the machine very effectively, not just from a machining perspective, but from maintenance and all of the rest of it. And we'll talk about keeping spindles turning, really, what this is about. So, Lee, give our listeners and our viewers just a quick overview of the compact range and why it has been introduced.
It's been introduced as an output from questions we asked our existing customers. You know, what could we do better in the future. So one big thing was footprint. We need to reduce footprint. We need to get more spindles per square metre into a factory. So whether it's standalone or whether it's linked into an automation system or cell, that was a big objective. Increasing performance and speed, and widening the range of options. But ultimately, it's all about reducing the cost per component for customers, whether they be steel, hard metal like titanium or Inconel, or even light alloy. So it's all about profitability for our customer base.
Okay, let's cover one thing off here quickly at the start, because part of our the purpose of this mini-series of videos we've created is to talk about the affordability of these machines. And it's no secret, a lot of our viewers will think, this wonderful machine behind us is out of their league or out of their reach. But it's not, is it?
Well, I think this is a massive misunderstanding in the market about Starrag. And I speak to a lot of customers, a lot of potential customers, people at trade shows, and the perception of Starrag is we are very high-end, very advanced, very high-tech, very expensive. And people just don't phone us up when they're buying a horizontal machining centre because they don't think we're into that competitive arena like other mainstream names, if you like.
And would you have associated this machine, Tom, with coming from the shop floor with in the company that you work for? Would it have been something, do you think, that you guys would have looked at, or would you have thought what Lee's just saying? These machines aren't for the subcontract machine shop. Would that have been an opinion of yours?
Well, until yesterday and actually speaking with Lee, yes, it was. I always thought Starrag was for, obviously, your big guys, your little machine shops. They just price well out your range. And I've always thought that, to be honest, until actually speaking with Lee and talking about this machine. And to be fair, they are a really affordable machine, which I think it is out there that everyone goes, oh, we need a new machine. What about, can't afford a Starrag? We'll not even inquire about one, because what's
They'll
the
rule
point?
it out straight away.
Exactly. And I think, like Lee was saying, I think that's one of the problems where people just see Starrag as this machine where we can't afford one. Where now, I think with this, obviously with this range as well, people just need to give them a ring, because they're a lot more affordable than people think.
Yeah, and that is a good point. If you want to contact Starrag, we'll put the details on the screen. You can contact Lee or his colleagues to find out more about the compact range after you've finished watching and listening to this podcast. Now, one of the first topics on this machine is probably one of the most important aspects of a machine is we're going to talk about the spindles, and we're going to talk about the spindle technology that you offer. Before we go into detail about what the options are and some of the features on your spindles, why is the spindle so important, Lee?
Well, we relate to a term called the tool chip interface, and that's obviously where the tooth of the cutter is in contact with your workpiece. So it's all about productivity, and it's all about the behaviour of that cutting process on a given range of materials or a given type of material. So assuming you've got the right cutting tool and you've got the right tool holder selected, we start, our interface is the spindle. So it's really important that we have the correct size of spindle, we have the correct power torque for a specific given material or a range of materials. And by doing that, if we optimise the capability of the cutting process, we produce parts faster.
So there is plenty of options with your spindles, though, isn't there? So talk to us about speed, torque, and where they fit. Because is there a one size fits all, and we don't have to get into the nitty gritty about 10,000, 12,000, 20,000, because we know there's a plethora of speeds that you can offer. But what I'm really intrigued to understand is what you would offer to, let's say, the market that we've been discussing, the subcontract market that can afford these machines. Quite clearly, they might be having a job that comes in one day that's a piece of titanium, and the next day an aluminium. So is there a one size fits all from that perspective? Because I know you've got high torques and you've got high speeds, but where's that sweet spot in between?
there's no such thing as a one-size-fits-all across such a wide range of materials. I think what we do that's different, nobody comes to us and says, I want a price and delivery for a machine and just give it me on a piece of paper. We always say to people, show us what you're trying to make, show us the materials you're cutting, the range of parts, the size of parts, and then we try and advise, and we start with the spindle. So that there's a range of motor spindles from 10,000 up to 30,000 revs. You know, a 20,000 rev spindle for us for an automotive type application goes from 0 to 20,000 and back within a second. So these are the kind of things we need to understand. Gear spindles range from 6 to 12.5 up to over 2,000 newton meters of torque. Then we have a DBF spindle where we've got a U-axis actually on the spindle. So for oil and gas or valve type parts, we can overturn, turn, face, put a gramophone finish on a part without using bolted on out facing heads. And then we've got quill type spindles, horizontally mounted or on a nodding head, swivel head type configuration. So you have to start with the component, how you're going to cut the component, shortest reach tools, most rigid setup, and define the right spindle. So if you wanted to cut aluminium and titanium, yeah, we do have a solution, but it's not 30,000 revs for aluminium. It's a slower spindle, still reasonably fast. I think if you went for a HSK 100 size, for example, we could offer an 18,000 rev spindle that's still got high torque for titanium. So it's a compromise.
Well, that's the breadth of the offering on the spindles. But some of the things that come as standard, and from a shop floor perspective, Tom, these guys on their machines have got the ability to sense vibration in the spindle, so you can quickly establish whether you're getting the best tool life out of your tool, or the machine will make you aware if there's any imbalances. You've also got is it water cooled spindles on your machine? You've got so many aspects to what comes as standard which enable you to get the best out of a spindle. I mean, have you ever worked with things like that, Tom? And would you see an advantage to being able to extract information from what's happening in there to make sure you get better parts and better economics on other accessories around the machine?
See, we had a machine with spindle cooling, so I've been down that road before, but having a machine that can see vibration in a part before you can, because let's be honest, sometimes if you're doing the back of a part, you can't see it. All you're doing is listening, you're trying to hear. But if you're in a machine shop with 10, 12 other machines running, sometimes it's hard. So if your machine,
and you're listening to your music and all that sort of stuff.
Exactly, yeah. If you've got radio on, and but if your machine's already relaying that back to you, then you can instead of sometimes you'll do one part and go, well, that's scrap because it's all vibrated down the back, but I couldn't hear it. With some of the features this machine's got, your scrap rate could be lower as well. And there's just another point I'd like to with the Starrag machine is, obviously sometimes you think of a spindle as your smaller machines will have a smaller spindle, and then your spindle will get bigger as your machine gets bigger, as you'd expect. But with some of your machines, you can have a HK 100 on your smaller machines, which obviously other people don't do that. So you think, oh, you've only got a small machine, you're doing small work. Yes, but there's
some
still
people
small parts made out of awful material.
Yeah, some people will buy a massive machine to machine because they think they can, because it's capable of machining small parts more effectively. But this, having an HSK 100 on a 400 pallet, is something that's pretty unheard of, I think, in the market.
Yeah, because like you said, some people buy a bigger machine than they need just because they need the spindle, but then you've got a metre bed and you're using 200 mil of it at the end. You're just wasting a big machine. You're wasting all the movement. If your machine's got to move a lot more, it's a lot heavier. It's got to. So if you can get a smaller machine but with the spindle you require, why wouldn't you go down that road?
Yeah, absolutely. Lee, I'm conscious of time here, so is there anything you want to add in about the spindles before we move on to the next subject? I mean, there's going to be plenty coming on the series of videos that we've shot, but
The only thing I would add to it is, and I was guilty of this when I was in the manufacturing end of the market rather than the machine tool end of the market. You take it for granted. You get a catalogue, you get a brochure, you get an email. It's a spindle. It's not a spindle. It's a very, very important part of the machine, and you should understand what is required from the spindle and make sure you get the right spindle. And there's lots of technology, like you say, vibration sensors, water-cooled, long-life greasing systems, etc., etc. They're there for a reason.
Yeah. Okay. Right. Let's move on to 4 and 5 axis. A point we often talk about on our videos is the fact that people don't adopt the 4-axis horizontal solution enough. They go for a 5-axis because they think that they need 5-axis when they might not need it. And you see a lot of these machines are going in around the world from Starrag that are just 4-axis, aren't they?
For sure, and it's a strange thing for us. In the UK, we always get asked for 5-axis. Everybody wants 5-axis. Joe Bloggs up the road's got a 5-axis, I want a 5-axis. Around the world, we sell many, many 4-axis machines, particularly for production parts that are 4-axis parts. So if you don't need a 5-axis, why buy a 5-axis? Unless you really want to future-proof your business and you don't know what's going to happen around the corner. So I don't know why we don't sell many 4-axis machines in the UK compared to our overseas colleagues. But the compact range is designed to be either a 4 or a 5-axis range.
And let's talk about the 5-axis build here, or let's talk about the bridge, the table, because these are important parts of every machine tool from the foundation up is built in a way and has a purpose to deliver parts in a faster way or in a quality or a better quality product. Tell us about how this is built, Lee, and some of the points you would like our audience to know as to why this configuration of machine should be considered and why it stands out.
Well, the way the machines are built, you've got a single monoblock base, if you like, with a column sat on it with a spindle in the column, so a horizontal spindle. And then the table groups, like a bridge, as you said, it's a bridge with 2 wide guide rails and measuring systems on each side. So on the top of that bridge, we then house either a single B-axis table for a 4-axis machine, or we put a trunnion, a very heavy-duty trunnion, on the top to make the 5-axis machine. So that's the way the machine's constructed.
And that table itself, it's kind of, if you drew a line down the middle of it, it's the same on the left as it is to the right, isn't it? It's identical.
Really important point, because not many people do this. A lot of people hang a table from one side, or they'll have a trunnion type table, but they'll have a big drive at one side and a small bearing and almost like a centre at the other side. So ours is fully thermosymmetrical. So if you look straight down the machine at the spindle and you look at the table, it's equal both sides. Large bearings both sides, large brakes both sides. So it's a very rigid, balanced system.
I suppose better from a wear perspective on the machine, isn't it? And mechanically would seem to be a better way to build it. I mean, there's less stress. If you're driving a table from one side, all the stresses are on one side, aren't they, as opposed to balancing that out from left to right.
Sure, I mean, it just makes sense in every way.
Isn't it,
you wouldn't have a car with a wide tyre on one side and a motorbike wheel on the other, would you? It's just not right.
I don't want to tell you about what's been happening with my tyres lately, but that's another story. Tom, 4-axis machines, you've been using vertical machining centres. Have you ever used a horizontal before?
No.
What would attract you to using one? Can you have seen, and I think this is a really important point in amongst everything we're talking about here, is the adoption of this style of machine from, let's say, a vertical machining centre. Plenty of machine shops might have 4, 5, 6, 10 VMCs, and you were working in one where there was a lot of VMCs. To me, you would have to move those parts a lot around the shop, or you might have a 4th-axis unit or something. Where's the comparisons you would make to a horizontal versus those type of solutions?
See,
because there's a place for both. I 100% get it, and I'm not saying one's better than another, but
I think, like you say, I think there's a place for both. I used 4th-axis quite a bit. I never got the jump to 5-axis because we never needed one. But like you said, I think there's a place for both, because obviously if you're doing one-offs and you're in the machine a lot, that's where I think your vertical comes in. But then with the horizontal, you get a lot better chip evacuation. and you can just hit it from more places. So.
You can stack up, can't you? It doesn't have to always be the same part. Let's get away from this thinking process that this machine is all about 200 of these. You know, it's not, is it? You could have a tombstone where you've got a set of parts on one face and a set of parts on another face, 4 different components or different operations.
Well, that's it, and I think that's another thing that comes back to the argument on why would you take a 5-axis over a 4-axis. I think sometimes 4th axis gets overlooked a little bit, because with 4th axis, obviously you need, I think, and I might be wrong, but I think 4th axis comes down a lot to your work holding, where with your 5-axis it's not as critical, because obviously you can hit more sides straight from the get-go. So,
but the more times you move that part around a machine shop, the more risk you're introducing, aren't you?
And I think there's a place for both, and also I think we're obviously, as Lee was saying, 4th axis is coming in a lot at the moment, is because people are just realising you can actually do a lot more with a 4th axis than people ever realised. If you've got the right work holding, you can actually complete a part. And obviously now with the with some of the softwares out there where you can tab things off, you can do parts in one. But then obviously when you've got the 5-axis, you can do that anyway, because you can just hit more sides. So I think that all comes down to product, what you're doing, what you're making. But then, like, going back to the horizontal, I think the horizontal is another thing that's really overlooked. Like, even for job shops, I think horizontal is overlooked, because sometimes at a job shop it's not all the 1 minute, 2 minute program. You can still have it on the machine for 3, 4, 5 hours. And I think with having a horizontal, it's great, because with that chip evacuation, like you said, you get better tool life because you're not cutting its own chips. And yeah, I think horizontal really does need more
adoption.
Exactly.
Just to update you, if you've just you've stumbled across this on YouTube or wherever you're watching, there is going to be a series of videos on the MTDCNC website that go into real detail with Lee about all of the points that we're discussing here on the new compact range from Heckert. Now, we're actually shooting this from the Nikken Innovation Centre in Rotherham. This is a fabulous place, a really great place to come to witness machinery like this in action. Now, we're going to talk about speed, power and accuracy, and we're going to try and move through these topics maybe a little bit quicker. So we're now 25 minutes into this podcast, and we're going to try and get things wrapped up by about 40 minutes. So speed, power and accuracy, Lee, what does that mean, and why have we picked that subject?
It means profit. That's what it means, because at the end of the day, if you buy a machine, you're buying a machine because you want to manufacture a specific component or range of components. So the faster you make them, the more accurate they come off the machine, and reliably accurate, so non-conformance, no scrap. Obviously you're not losing money that way, and the power goes hand in hand with the speed. The more speed and power you've got, the faster you can produce parts. It's as simple as that.
I said to you yesterday when we were filming, I said to you, okay, I know what people will say. I've been in machine shops, and people will say that machine looked really quick, it could make my part in 50% of the time, but then I'm going to run out of work and I've got nothing else to put on it, so I've got a machine that's idle. What's the point?
Well,
you're a salesman, what do you say to that?
Win some more work. I mean, this machine will win work for companies, and it is 50% faster or more in many cases. I mean, we do time studies for people, and we did one recently. We were 20% of the customer's time. They didn't believe us. We cut apart. Wow, people have to throw these challenges.
But did they come up with that objection that I've just said? Did they say, okay, so you're making this 20% of the time? What am I going to do for the rest of my time?
No, but that would
have been a very negative response.
It's a very negative response. I think the UK supply chain doesn't think in that way. I think the UK supply chain thinks, wow, I've got 50% capacity, I'm going to fill that up. But you can also fill it up with parts you can machine 50% faster, so you're effectively twice as fast over a year.
When you look at when you look at the speed of these machines, talk to us. Well, do you know anything about jerk rate, Tom?
Not really.
Okay, so Lee, just explain to us about acceleration, jerk rate, how important it is, because it's huge, isn't it?
It's very important, and people talk about feed rates. So let's say you're in a small pocket. You've got to start from 0 feed rate, get up to your programmed feed rates. You've got to slow down for corners, etc., etc. So acceleration and jerk go hand in hand, and it's the ability to get from 0 up to speed and back down to speed. So the more small movements you've got, the more this comes into play. People don't consider this. They just think, oh, it's got this speed, it's got that feed. There's a lot more depth you need to go into the power requirements, into the acceleration and jerk requirements, and really look at how fast can you produce that part.
A bit like a drag racing car, is it? Getting up to top speed as quick as possible.
And back down again. Yeah. And when we go back down in speed, we use that kinetic energy we produce to decelerate to drive the machine.
Okay, so savings in efficiency
for sure.
As part of that. When you're moving so quickly, does that have an effect on the build of the machine and the mechanics and everything that goes with it? You imagine that car that's accelerating really fast, everything that's in it has got to keep up, and then it's got to slow down again as quick. Is there any knock-on impact as a result of being so quick?
Of course there is. So this is why our designers, when they were set to task on this machine, took all those factors into consideration. We talked at length about the spindle. Every feature of the machine has that depth of technology in it, so that the finite element analysis of the structure in dynamic mode, not just static mode. The materials we use for the base, we use a polymer material that's extremely absorbent to vibration, but it's also extremely resistant to thermal behaviour. The wide bridge, the wide rails, the big rails, the type of rails, everything's designed on this machine for speed, rigidity, and ultimately the fastest machining time possible.
And to make parts accurately.
For sure.
And of course that is what everybody desires and needs. Work holding on a machine like this, let's touch on this one briefly. How do you go about putting your fixtures on here, your tombstones? Is it a messy process? Is it quick? Is it secure? Tell us about that.
We talked about the tool chip interface at the start of this discussion. It's just as important when you look the other way from the component back into the machine. So we start with the tables. We make our own tables. We manufacture tables to less than half the tolerance. I think it's a VDI tolerance for machine tables. We don't work to that. We work to our own tolerances. We grind the top surface of tables. So when you put a fixture on a table, you've got a perfect location. Now you can use a manually operated clamp, but more often these days people are moving to hydraulic clamping systems. So there are various ways we do this, but you can have a system where we've got up to 13 ports, hydraulic and pneumatic combined, to control the clamping of workpieces and to control and make sure that workpieces are actually loaded properly and in the fixtures properly. And even on the mill turn centres where we can rotate at 900 revs, we've still got direct control of that clamping process even when high-speed turning.
Because if you were to, Tom, when you look at having work holding and fixturing and hydraulic things on machines, for me, in days gone by, I always associate loads of hoses and pipes everywhere, and but that's not the case on here. You can see it's right through the centre, isn't it, Lee? It's completely hose free.
It's hose free. It all comes through the table. So there's a connecting mechanism through the centre of the table that the fixture just drops onto, automatically sealed and with programmable ports. So for example, if you have a component you need to rough very heavily, but the component's likely to distort, you can clamp it hard to rough. You can then release the pressure of those clamps, so you're clamping it lighter to finish, so you're tuning out any potential distortion. And it's all programmable through M codes.
And could you have seen risks with that when you were clamping parts and putting fixtures on tables? there is risk to machinists, isn't there, if you don't have some of the securities in the process that Lee's talking about?
Oh yeah, because it's all right having your part clamped correctly, but if you're heavy roughing, you can end up moving your fixture. So if your fixture's not secure, or it's just not right, then it's never going to work.
And has that ever happened to you?
I don't want to talk about it. But there's just one quick point I want to say about this machine as well, which is another thing that's really clever. Like obviously we think of clamping and stuff. There's hoses everywhere, so you could fixture something. All the hoses, yep, that's fine. As soon as you hit it flies off. But with this machine, it's actually got sensors to show that if the fixture isn't correctly clamped, it won't let you run it. So it's even got the safety features on it as well, which could help some people.
Absolutely, it could have helped you when you
don't want to talk
had
about
that accident, which we won't talk about. Go on, Lee. Go on.
Just one more point on that. When turning, you've also got an in-balance function on the machine as well. So if for any reason there was an unbalanced component or an unbalanced fixture, the machine tells you it stops. It tells you what weight to put where, and you're away.
Okay, incredible. Just another aspect of the technology available on this compact range from Heckert. Now I just want to talk about two things together because I think that there is synergy in them. These are multitasking machines. They have the ability to be automated, as we see here, with a twin pallet or even a gantry system. You can have FMS systems on them, so you can really keep them running lights out. But with that, there are certain things that you have to consider. There are the tooling element, there is swarf evacuation, there is control over the process. It's easy to just go, right, okay, I'm going to add another 10 pallets to a machine, but what else have you got to consider, and what does the Heckert machine give you to enable you to run unmanned successfully?
Well, for a start, all of the machines are a twin pallet, so they're all automated anyway. We do an option on this compact range called the L range, where we remove a pallet so that the machines can be connected to an overhead gantry system, but that's an automated system anyway. So as a standalone, they're automated with twin pallets. What we then do in many cases is we link to a palletized FMS type system, or we can link to a robot. We can link multiple machines to a single robot. It really depends on customer requirements, volumes, mix, and how much money people want to spend.
What about sister tooling? What about making sure that when I go home and press the button, if there is an issue, it moves on to the next job, the next tool, the next, it factors in all of those things.
Factors in all those things. So as a standard, the machines are available with 40 up to over 400 tool holders, depending on the configuration. So again, these are the discussions we have to have with customers early doors. On top of that, then, depending on the workload and how the system is programmed, if you like, there's a cell controller usually on an FMS that will say, okay, I want to make 10 of those, 10 of those, 10 of those. It'll look ahead. It'll say, okay, I've got the tools or I haven't got the tools. It'll look at sister tools, and it'll make sure it's got sufficient capacity within the machine to run through a weekend or a bank holiday or whatever they want to run unmanned.
And you've got tool inspection, you've got part inspection, you've got all of those options that come with or can come with the machine.
Everything. So I mean, normally on a machine like this, you would set the tool off the machine, maybe have a chip system like a Balov chip system or similar, or a coding system, so that the operator doesn't have to punch numbers into the machine. It's all automatically transferred. Like you say, you've got your tool management system. You can probe components before you start to make sure they're in the right place, or if they're a casting, that they're the right size casting. There's adaptive machining systems to make sure you're not wasting your time cutting fresh air. You can measure on the machine. You can cut, measure, cut. There's virtually nothing you can't do.
There's two more points we're going to cover, and then we're going to.
Can I just jump in
just
before we start? Just on the process integration with this machine. Now, I spoke with Lee a bit yesterday about what this machine can do and how it can help. So obviously sometimes in a job shop you've got to turn a part, you've got the mill apart, but then you've got to grind a part. But on this machine, you can do all that in one go. And like Lee was just saying, you can actually mill, turn, grind, and then you can measure the part and go, oh, wait a minute, that bore's undersized, and the machine will automatically alter, regrind it, So you know when you're talking about lights out machining, you don't want to set your jobs running and then come back, set them running on a Friday, come back Monday morning and go, well, that bore's out, I've got to remachine it. The machine will make sure that when you'll have the confidence in the machine that when you leave on a Friday and come back on a Monday, that all your parts will be to size because the machine will have checked them for you. And also with the checking system, sometimes you make a part, you've then got to take it off, you've then got to go and CMM it. But then if you're doing a bore to micron tolerance, you've then got to get that back on machine and clock that part back up absolutely spot on. This machine does it for you. And with it not going from machine to machine, like we've said before, that's less human error, because let's be honest, if a machine ever goes wrong, it's never the machine, it's always the person who's programmed it. And I don't like to say that because I'm a machinist and I'm never wrong, but we're always there. So just having that confidence in when I come in on a Monday morning, oh no, are them parts going to be scrap? Are they going to be undersized? No, you've got the confidence with the machine and with all the safety features it's got to go. When I come back in, I'll have, if you've got a part, you'll have 2 parts completely finished, ready for the customer.
Yeah, so important. And a big aspect of everything to do with the compact range that we're talking about here from Heckert. Now, I just want to, just two very quick points that we're going to touch on, Lee, and there will be more detailed videos on our YouTube channel about every aspect that we've discussed, plus more. The HMI, the control system, operator friendly, great from a maintenance perspective. Just explain briefly how good your interface is.
Again, this is a relatively new interface. It's a flat screen, twin screen configuration, I suppose you could say. I mean, I have a twin screen on my desk at home when I'm working on one side on one job, and on the other side I've got some other information. It's just the same. So on the left-hand side of the screen, you're looking at the data that you would see on any other control system to control the machine. Behind that, there's also specific Heckert functionality, very easy maintenance, operating, setting, systems, options, and you can either use the right hand side of your screen, as we have been doing yesterday, to show the camera inside the machine. We can pull setup sheets, we can pull maintenance instructions, you can push Industry 4 instructions down to the operators and the shop floor. So it's a real interactive user system, and we've got several of these in the UK now, and the operators absolutely love them.
And you can come here to the Nikken Innovation Centre and see this machine and kind of touch and feel and have a play with what Lee's talking about. Guys, I know we've probably got 1,000,001 things we could continue to talk about on this podcast. I want to just summarise what we've discussed and talk about the fact that this compact range is about having a bigger machine in a smaller footprint, isn't it? You've got a lot of capacity in this horizontal machining centre, horizontal 5-axis, when you consider the footprint of it compared to what the working area is. That's one of the big aspects too.
Sure it is. So one of the objectives from our existing customer base was to say make the machine smaller. So hence the reason we've called it the compact range. But within the inside of the machine, we've lost nothing. We've still got very good axis strokes for the size of the machine. And as we've said, we've got lots and lots of different modules to configure the machine so it's optimized for specific processes. I think the really important message for people when they buy machines is don't look at just the cost of the machine. Look at the total cost of ownership of the machine. Look forwards 5 years, 10 years, 20 years as to what you're going to make from the machine, not just the cost. Having said that, though, our designers have designed this in such a way that it is a very competitive machine. You get a lot of value for money, and it's not really a lot difference in price than other lesser machines on the market. So that's going to be interesting going forwards as to how many calls we get for these machines.
And it's definitely worth getting in contact with the guys from Starrag about this machine. There's a few points I would conclude with that I've picked up in my 2 days with Lee. Utilising technology like we've got behind us will help you win more work. That's a very clear message. It will help you make parts consistently to a quality that your customers will like. It will improve your productivity, and if you look at the cost of ownership with the things like efficiencies and cost savings and uptime, this machine could be a solution for you. Gentlemen, it's been a pleasure. thank you for joining us both. Tom, thank you for your input. Lee, it's been a great couple of days with you. Contact Lee Scott direct, or his colleagues. We'll put some details in the on whatever social channel you're watching this on, so you can contact the guys if you want to know more about the compact range from Heckert. Thank you very much, guys, and that's it for this MTDCNC podcast.
Thank you very much.
Thank you.
Thank you.
Thanks for listening to the MTD podcast. If you found value in this episode, please subscribe and leave a rating and review. Find more episodes on mtdcnc.com.